medium problem today. We have, let's look, string and pattern, and we want to find subsequence of this string to match this pattern and return the indices. But we also can change at most one character at position. So this problem is marked as medium, 10 to the power of 5 size of the strings, so should be solved in linear time. And I personally didn't solve it but let's look at the solution. So first, imagine we have this pattern like BAC, okay, BAC, and the string has like C, BA, and we can double that like C, CC, BB, A, some D maybe. And we want to first we want to find from this pattern where each last position is. So we have C, and it goes here. From CCC it goes into the last C, and entire suffix got skipped, so we don't have any matches for B and A. And if we have different combination like maybe A, C, and B, like BB, AAA, CC, some other letters, and the same pattern, BC. We compute in this jump table. So for the C, it goes to the first C from the tail. From A, it goes to the first A, and from B, it goes to the first B. After that, we iterate from the left to the right, and we doing the matching like B match B, then we take it, and then we have B and A, and as we allowed to skip or change, then we ask ourselves, so is this can we take it and change, like for this A, what was the last position? It is this one, and that means everything after this is guaranteed to be matched. So this is AC is guaranteed to be presented as a substring. So we just can do this change, swap, if it didn't match. So B doesn't match with C, with A, and that means and current position I is before this suffix. So we can safely take and change, like match B with A, and say that yes, we take in this position, it would be a swap, and then we take C. So another example like this one. So we have BBB, G, CC, AAE, and the pattern CBA, and we say that A goes to the last A, B goes to the last B, and C doesn't have anything to match. because we already used this ba. And then we checking from going from the left to the right and matching b with c. And we asking ourselves, can we actually match them or not? And so basically, can we swap or not? And for that we looking at the next. So we want to exchange C to B, and we're looking at the next. So if we change that, can we safely say that B is already, so we already used our exchange X use, so the suffix should match totally. And to guarantee that, we have to check where the last B is. So the last B is here, and we say that current position is before the last B. That means after current position we have perfectly matched. I already checked suffix, so that means we can safely exchange C to B. This is how it works. And to build these suffixes, we go from the tail with 2 pointers. As we first see first match, we're advancing this button pointer, and this pointer goes into range. So let's look at the code. This is a accepted version. I didn't solve it myself, as I said before. 40 minutes just to find a good solution explanation. So this is last. It is answering the question. So after this position, we should have perfect subsequent match. So if we have like last of B equal 0, because we pointed to 0. Oh no, it pointed to 1. So that means this is entire match. So if last I equals some index j, like this, j, that means after j, after last I, perfect match of the substring. So like answering the bestpoke match. So we go and advancing it like we don't have any other properties, just advance them and hope everything works out. So greedily, as we first see in this match, we're advancing pointers, and this is like lazy low effort solution, and we can use it to make it high effort implementation later. So and then we go from left to right of the entire first string, and if we have a match between button and string, we just say that's okay, we're taking it, advancing the pointer. And if not, if they don't equal, we are checking if the suffix is perfect match. So, and if we before the suffix, if we're not intersecting the suffix, if we can take the suffix entirely. So this is why we check comparing I with last j plus 1. And if we are, then we take it. Basically we exchanging, and this is just single operation for the entire program run. It didn't execute more than once, so we have the skip flag. As I would say, this is gated by skip, and then first leg, second leg, then we usually then we go and finish this line, and we check, have we achieved the perfect match? So is our J is perfectly T length? If not, we can drop everything. Now let's look at the code that is a little bit shorter. What is this? I don't know. This is Rust solution. Same, but Rust is a little bit tricky because it has usize, and if you do 0 minus 1 for the usize, you are in a bad situation. So you have to be careful with -1. I put it to the left, because if we put it to the right, and it first would be 0, 0 minus 1 gives usize max, and this equation would be true, however it's false. So Rust gives you and this is my cat. She solved this problem. She is better solver than me. That's why she don't have to work. Okay, that's it for today.